Welcome to the deep dive. So I was thinking about this earlier. If you're anything like me, you probably have a junk drawer somewhere in your house.
Absolutely. Everyone has one.
Right. It's like that place in the kitchen or the hallway where you just toss the spare batteries.
Yeah, or like those random screws from an IKEA kit that you didn't use.
Exactly. The Allen wrenches, the rubber bands, things that just kind of, well, they just exist and you accept that they belong there because you don't know where else to put them.
You just close the drawer and pretend it makes sense.
Yeah, exactly. Well, today we are looking at a stack of source material, specifically a really dense theoretical physics paper from March 2026. And it argues that modern physics has basically been treating the entire universe like one giant junk drawer.
It really is an apt comparison. I mean, if you look at the current consensus in physics, specifically the standard model, it is incredibly successful. Like, it's amazing at predicting what particles will do.
All right, it works.
It works perfectly. But underneath all that success is this foundation built on roughly, 26 fundamental constants.
And these are like the numbers we just have to accept, right?
Yeah, exactly. The mass of an electron, the speed of light, the strength of gravity. These are just numbers that we've observed and measured, and we basically just accepted them. We don't actually know why they are those specific numbers.
Which is crazy when you think about it. Like, I remember being in high school physics, sitting there with my clunky TI-83 calculator.
Classic.
Right. And having to memorize that the gravitational constant is, let me think, 6.67 times 10 to the negative 11th.
Yep, that's the one.
And if you ask a teacher, like, why is it that specific messy decimal, they just sort of shrug. They tell you, well, we measured it, and that's just the number.
Right, which really implies that the universe is just this, like, collection of arbitrary dials. And somebody, or some random process, just spun them and left them there.
Like someone just threw a bunch of random numbers into the junk drawer.
Exactly. It's an entirely empirical approach. We observe, we write down the result, but it lacks a deeper underlying reason, like what is the actual mechanism?
Which brings us to the real centerpiece of today's deep dive. We've got this paper by George James Dukas. It's titled TDUFT, Maxwell Revised.
Which stands for Transdimensional Unified Field Theory version 3.
Right, version 3. And this framework attempts to do something just breathtaking. I mean, it aims to pull up the floorboards of modern physics, toss out that entire junk drawer of 26 arbitrary constants, and replace them with a single unified geometric structure.
It's a massive undertaking.
It really is. It wants to take the equations we've used for, 150 years to describe what electromagnetic fields do, and finally explain what they actually are made of.
Because that ontological gap, it's been sitting there since the 1860s.
Since Maxwell.
Right. James Clerk Maxwell gave us the absolute gold standard equations for predicting electromagnetic phenomena. I mean, we literally built the modern electrical grid, radio, the internet, all of it on his math.
Yeah, you can't argue with the results.
No, you can't. But Maxwell's equations are purely descriptive. They tell you what happens, but they don't give you a physical mechanism for the fields. And TDUFT attempts to provide that mechanism without, resorting to the usual modern workarounds.
Okay, let me stop you there. Because whenever I hear, like, a new theory of physics, my brain instantly goes to string theory.
Oh, sure.
I just picture, like, 11 curled up invisible dimensions. Or infinite multiverses where every possible reality exists. And as a layperson, honestly, it always feels a bit like cheating.
Yeah.
Like when a theory relies on things we can never, ever observe.
I totally get that. And what's fascinating here is how grounded Dukas's approach claims to be. Like, there are no untestable multiverses in TDUFT.
Thank goodness.
Right. Instead, it introduces this concept of the eternal philatus. So instead of viewing the vacuum of space as just this empty void where particles occasionally bump into each other, the paper treats the vacuum as an active, recursive, geometric medium.
Meaning space isn't empty.
Exactly.
Yeah.
Space itself has a shape.
Yeah.
And it's a shape built entirely on the golden ratio.
Okay, I really want to look closely at this philatus. Because if we are throwing out all those messy constants I had to memorize, we have to replace them with something.
Right.
And according to my notes on this paper, Dukas replaces the entire complex machinery of the standard model with just 2 numbers.
Yep, just 2.
I mean, replacing the whole universe with 2 numbers seems wildly arrogant.
It sounds totally reductionist, right? Yeah. Until you see the math it's built on, the entire framework rests on arguably the simplest quadratic equation in all of mathematics, which is x squared minus x minus 1 equals 0.
Okay, let me jump in here. Because a quadratic equation always has 2 solutions. or two roots, right?
Right.
And the roots of x squared minus x minus 1 equals 0 give us the golden ratio.
They do. And in this framework, those two roots act as the fundamental operators of reality. So the first root is phi, phi, which is a positive number, approximately 1.618. TDUFT assigns phi as the velocity operator. Its whole nature is inherently expansive. It basically governs how energy and information propagate outward through the dimensional tiers of this lattice.
Outward. Okay, and the second root.
The second root is psi, which evaluates to approximately negative 0.618. And this is the time operator.
So it's negative.
Right. Unlike the outward push of phi, psi is contractive. It governs closure, density, and how geometry folds inward on itself.
Okay, wait. In the physics classes I took, velocity is just like how fast my car is going down the highway, and time is just what my watch measures. They're just units. But you're saying this paper treats them as geometric actions, like they're the actual physical architects of space?
Yeah, think of them as the verbs of the universe rather than the noun.
The verbs. I like that.
They are passive measurements, and the relationship isn't just like loose. It is locked by a really rigorous algebraic identity. The paper repeatedly hammers on this one equation. Phi to the negative 1 plus phi to the negative 2 equals exactly 1.
Exactly 1.
Yes. The author stresses this is not an approximation. It's not a rounding trick to make things look neat. It is an exact mathematical truth demonstrating that two-dimensional space, which is the foundational layer of this lattice, is fundamentally self-consistent.
Okay, let me try to visualize this, because I need a picture in my head. If I just close my eyes and picture the universe breathing,
Right.
taking a breath in and letting it out. Phi, that positive 1.618, is the outward exhale. It's light, it's energy, it's the push expanding outward into the void.
Okay, yeah.
And psi, the negative 0.618, is the inward inhale. It's the contraction, pulling that energy back into like dense little knots, which we eventually perceive as mass and gravity.
I see where you're going with that, but let's refine that analogy just a slightly. It isn't a sequential breathing in and out.
It's not.
No, it's simultaneous. Additive geometry governs the physical points in the lattice, the actual structure itself, while multiplicative waves govern the connections, or the tension between them. So the expansion of phi and the contraction of psi are happening at the exact same time, balancing each other perfectly across different dimensions.
Oh, wow. Okay. I get the philosophical appeal of that. It really paints a picture of a deterministic arithmetic structure rather than a universe that just, accidentally stumbled into the perfect conditions for life.
It's very elegant.
It is. But I have to push back here. Because the standard model has quarks, leptons, strong and weak nuclear forces, Higgs bosons, it is immensely complicated.
Oh, undeniably.
How can you possibly derive all of that complexity from a basic algebra equation and a golden ratio?
Well, the complexity we observe doesn't necessarily require complex foundational rules. Think about fractals.
Like the Mandelbrot set.
Exactly. A Mandelbrot set is infinitely complex visually. You can zoom in forever. But it's generated by repeating one incredibly simple equation over and over. TDUFT argues that the entire particle zoo of the standard model basically emerges from the recursive, repeated application of phi and psi across different depths of the vacuum lattice.
So it's all about layers, just repeating the same rule at different scales.
Precisely.
Okay, I want to see the receipts on this. Let's take those two numbers and apply them to the constants we actually use in the real world. Let's talk about Maxwell and the vacuum.
That is the perfect place to test the theory. So James Clerk Maxwell gave us two very specific constants to describe the baseline nature of empty space. There's vacuum permittivity, denoted as epsilon sub 0, and vacuum permeability, denoted as mu sub 0.
Okay, let me make sure I have this straight for everyone listening. Permittivity is basically the vacuum's ability to store an electric field, right? Almost like a sponge holding water.
Yeah, that's a great way to think of it.
And permeability is the vacuum's resistance to a magnetic field passing through it.
That is the functional understanding, yes. And for over a century, we've measured epsilon 0 and mu 0, and we found them being incredibly messy, specific decimals. They are entirely foundational to electromagnetism, but standard physics has absolutely no explanation for why they hold those specific values.
They're just more junk in the junk drawer.
Exactly. But TDUFT claims they aren't arbitrary decimals at all. They're exact geometric ratios of phi and psi occurring at specific dimensional boundaries.
Wait, I'm looking at the formulas here in the paper. It says vacuum permittivity, the electrical storage is simply phi squared.
Yep.
And magnetic permeability, the resistance, is phi cubed over psi squared.
And here's the kicker. When you plug the golden ratio into those really simple exponential expressions, you get the exact values we've been measuring in our laboratories for 100 years.
Wait, really? The exact values?
Yes, the electrical and magnetic properties of empty space are just golden ratio geometry. It maps perfectly.
That is wild. I mean, if that's true, it means space isn't just an empty container that things happen inside of. Space is the active machinery itself.
It's the engine.
And this brings us to what the paper calls Dukas' third law, which honestly seems like the most aggressive claim so far because it tackles gravity.
Oh, yeah. It requires a massive paradigm shift.
Okay.
Dukas' third law states that G, the universal gravitational constant, is exactly equal to 1 over psi to the fourth power.
1 over psi to the fourth power, that's it.
That's it. Let's break down what that means structurally. Because in prevailing physics models, gravity is an outlier. It's this totally separate fundamental force governed by general relativity, and it notoriously refuses to play nicely with the quantum mechanics that govern electromagnetism.
Right, that's the whole quest for quantum gravity. They don't mix.
Exactly. Well, TDUFT throws that separation completely out the window. It claims that time, density, and gravity are the exact same operator. They're all the psi operator, just acting at different depths of the lattice. So gravity is simply the reciprocal of a fourfold temporal contraction.
Hold on, wait a second. If gravity is just time contraction, why does an apple fall down toward the Earth? I mean, if time is just contracting, why wouldn't the apple just sit in midair and age slower? Why is there a directional physical pull?
Because of the density gradient. Think of the Earth as a massive knot of psi contraction.
A knot.
Right. The closer you get to the center of that mass, the stronger the temporal contraction becomes. The lattice is literally pulling inward, folding tighter and tighter on itself. So the apple isn't being pulled by some invisible rope. It is simply following the steepest path of the geometric gradient.
So it's just moving toward the region of maximum density.
Exactly. The gravitational field is just the spatial consequence of that deep temporal contraction.
Okay, so a heavy planet is like a region of space that is aggressively zoomed in on itself.
Yes, zoomed in.
And gravity is just the optical effect, basically, of the surrounding vacuum falling into that zoomed-in, dense pocket. It's a structural property of the medium.
You've got it perfectly.
But let's do the math on that. Does 1 over psi to the fourth actually equal the gravitational constant Newton gave us?
Let's run the numbers. So if you take the absolute value of psi, which is 0.618, and you raise it to the negative fourth power, you get 6.854, and the decimals continue.
Okay, let me look up Newton's constant again. The accepted value of G is 6.67 times 10 to the negative 11th.
Now notice the scale. The geometric operator value, the 6.854, perfectly matches the macroscopic scale of Newton's 6.67.
Oh, I see.
Right. TDUFT derives the fundamental scale of gravity strictly from the geometry of time contraction without introducing any extra parameters, no fudge factors. And structurally, stronger psi density means a weaker effective gravitational radius.
I see the similarity in the numbers, but 6.854 isn't exactly 6.67. Is that slight difference accounted for, or is it just close enough?
No, the paper actually addresses that variance. It explains that our human measurements of G are taken from within a highly complex, chemically messy environment, meaning the Earth,
Right.
which introduces secondary geometric interference from the planet's own atomic lattice. But the baseline magnitude is a direct hit.
Okay, so if Maxwell's constants and Newton's gravity are just the visible, macro-level effects of this deeper golden ratio lattice, it implies that classical physics missed a whole lot of the underlying plumbing.
Maxwell mapped the surface perfectly, but he just lacked the tools to see the depths. And that limitation is actually the basis for one of the most explosive assertions in the whole TDUFT framework.
Let me guess. The two types of magnetism.
Exactly. The identification of two entirely separate types of magnetism.
I really want to dig into this because in everything from my high school textbook to like advanced engineering manuals, there is only one magnetic field. We denote it with the letter B. Whether it's a magnet holding a grocery list to my fridge or the Earth's magnetic field deflecting solar radiation, it is all the exact same phenomenon.
That's the classical view, yes. Classical physics treats all magnetic fields as expressions of a single underlying force. But TDUFT separates them by dimensional depth.
How so?
So the field we are familiar with is what the paper calls D6, or electric magnetism. This is the classical field generated by moving electric charges. When you wrap copper wire into a coil and run a current through it to build an electric motor, you are generating a D6 field.
Right.
The formula for it is simply force multiplied by charge area.
And crucially, based on what I read, these D6 fields close locally. Like the magnetic field lines loop directly from the north pole of your electromagnet back around to its south pole. It's completely self-contained.
They loop back entirely within their local dimensional shell. That's the key. But TDUFT introduces a second field, D10, or field magnetism.
And what generates that?
Well, that's the thing. It is not generated by moving electrons in a wire. It's the magnetic field of the vacuum itself. It is generated by rotational induction, coupling directly to the lattice.
Directly to the lattice.
Yes. Structurally, it is the product of density and gravity volume.
Okay, let me try to wrap my head around this with an analogy, because I need to picture the separation. If I think about a heating system in an old house, you have radiators, right?
Sure.
The water in the radiator gets heated, circulates through the metal fins, and loops back to the boiler. It's a closed loop. That's our classical D6 field. It does work. It moves energy, but it is totally contained within those specific pipes.
The water never leaves the radiator.
Right. And classical physics basically looked at the radiator and said, this is the entire universe of water.
Yes.
But TDUFT says that underneath the house, there is a massive high-pressure underground aquifer. That's the D10 vacuum field. The radiator is just this tiny visible mechanical loop, but it exists on top of this totally invisible reservoir of geometric tension.
The aquifer analogy works so well because it highlights the separation. The unified equation in TDUFT uses the imaginary unit, the square root of -1. It uses it as a dimensional rotation operator.
Yeah.
When you square I, you get -1.
Yeah.
So the math literally encodes the fact that the D6 local radiator and the D10 vacuum aquifer are in strict orthogonal opposition to each other. They operate at right angles dimensionally.
Oh, wow. So they can't normally interact all. The water in the radiator can't just spill into the aquifer.
Exactly. They are mathematically partitioned. And this explains the historical blind spot. If you take the TDUFT unified equation and you set the D10 term to 0, basically pretending the aquifer doesn't exist, the equation collapses perfectly into Maxwell's original classical formulas.
No way. So Maxwell's math wasn't wrong. It was just truncated.
Yes.
He was describing a universe where the aquifer didn't exist because his experimental tools like classical coils, batteries, compasses were just radiators. They were locally closed systems that just didn't leak into the higher vacuum dimensions.
Maxwell only mapped the D6 shadow.
Yeah.
He couldn't see the aquifer. And what's really cool is this dual field concept also cleanly resolves one of the longest standing frustrations in modern physics,
Which is
the missing magnetic monopole.
Oh, right. Because if you take a bar magnet with a north and south pole and you snap it in half, you don't get a piece of metal that is purely north and a piece that is purely south.
You never do.
You just instantly create two smaller magnets, each with its own north and south. The loop always closes. And particle physicists have spent decades smashing things together, trying to find a monopole like an isolated north or south charge, and they never, ever find one.
Exactly. Classical physics has incredible mathematical models for monopoles, but absolutely no physical explanation for their absence. TDUFT answers the puzzle geometrically. Neither field allows for monopoles because both fields fundamentally close back on themselves. They just close at vastly different scales.
So D6 closes locally.
Right, through the loops of moving electrons. And D10 closes globally through the overarching geometry of the vacuum.
So they both make full circles, just in different dimensions.
Exactly. Furthermore, the paper posits that D6 and D10 aren't the end of the story. They are merely the first accessible rungs of an infinite B-field ladder, with magnetic fields extending upwards into higher and higher dimensional closures.
Man, this is a heavy conceptual lift. We've established that the universe is a breathing lattice and that this vacuum has its own hidden magnetic depth. But if space isn't an empty void, if it's this incredibly structured active grid, how does light travel through it?
That's the big question.
Right, because light is the ultimate cosmic measuring stick. If I shine a laser pointer, that light has to be interacting with this golden ratio lattice, doesn't it?
It does, and in a highly specific way. In the TDUFT framework, the speed of light, c, is not a fitted constant. In standard physics, c is the cosmic speed limit, but we don't really know why it's exactly 299,792,458 meters per second. The universe just seemingly enforced that specific number.
Another junk drawer number. Exactly. But TDUFT argues that C is a strict geometric necessity derived from the foundational identity we discussed earlier. Phi to the -1 plus phi to the -2 equals 1.
Okay, but I have the paper in front of me, and looking at the math here, there is a serious discrepancy.
Oh, the 3.0 thing.
Yeah. Dugas claims the baseline propagation speed in D2 space,
Hmm.
which is the fundamental 2D layer of the lattice, is exactly 2 plus phi to the negative 1 plus phi to the negative 2, all times 10 to the 8th. Since that phi section equals exactly 1, that makes the baseline speed exactly 3.000000 times 10 to the 8th meters per second.
A perfectly clean, flat integer.
But the measured speed of light is not 3.0 flat. It's 2.99792,458. That is a well-established measured fact. So is the paper just rounding to make the math look pretty?
No, not at all. The paper acknowledges the discrepancy and actually uses it to prove the existence of the dimensional layers.
So the baseline speed of light is exactly 3.0 in pure D2 space. But we don't live in or measure from flat 2D space. We are measuring light as it propagates through our D3 spatial environment. As the D2 light wave moves through the higher D3 space, it faces geometric resistance from the lattice.
Okay, I'm trying to picture this. It's like throwing a baseball underwater.
Close. But a baseball implies a physical object facing friction. Think of it more like an Olympic sprinter running on a perfectly engineered track. Their theoretical top speed, based on their biomechanics, is a flat 3.0.
Okay.
But the race isn't taking place on a dry track. The track is covered in a few inches of shallow water. The water doesn't stop the runner, but it creates a consistent structural drag that brings their actual speed down to 2.99.
Oh, I see. The 3D space is the water dragging on the 2D propagation of light.
Exactly. The geometric drag attenuates the speed from exactly 3 down to the 2.9979 value we measure. But the truly staggering part of this section is the specific mathematical tool Dukas uses to calculate that drag. The attenuation relies on the Ramanujan-Rogers continued fraction.
Wait, Srinivasa Ramanujan, the self-taught Indian mathematician from the early 1900s who claimed his mathematical formulas came to him in visions from a goddess.
The very same. In 1914, he sent a letter to G.H. Hardy at Cambridge containing just a mind-boggling array of formulas, including his continued fractions.
What exactly is a continued fraction?
It's essentially a fraction where the denominator contains another fraction, which contains another fraction, extending infinitely. It creates a sort of mathematical Russian nesting doll. And for over a century, the Ramanujan-Rogers continued fraction was celebrated as a piece of pure, abstract, beautiful mathematics. It had absolutely no known physical application.
So you're telling me a purely abstract equation scrawled in a notebook by a mathematician over 100 years ago perfectly calculates the physical drag of a photon moving through the vacuum of space?
Yes. TDUFT gives the Ramanujan-Rogers continued fraction its first physical interpretation.
That gives me chills.
It's incredible. The infinite nesting nature of the continued fraction perfectly models the fractal pentagonal symmetry of the phi lattice pulling on the propagating wave. It mathematically represents the structural resistance of space itself. Furthermore, the 2 in the baseline equation, the 2 plus phi to the negative 1, that 2 represents the base of the D2 space, which inherently forms a tetrahedral wavefront.
A tetrahedral wavefront. Okay, so light isn't a tiny little spherical bullet shooting through an empty void. It is a specific geometric shape, a tetrahedron navigating a pre-existing geometric grid.
Exactly. And framing light as a topological shape finally explains the deepest mystery of relativity.
Which is why the speed of light is invariant. Why it looks the same to every observer regardless of how fast they are moving.
Yes.
Because that has always broken my brain. If I'm in a spaceship flying at half the speed of light and I shine a flashlight ahead of me, the light from the flashlight doesn't travel at 1.5 times the speed of light. It still only travels at 1.0 c relative to me. In classical mechanics, speeds add up. In relativity, light refuses to go faster.
And TDUFT explains this through topology. You cannot change C because you cannot physically stretch, compress, or alter the fundamental combinatorics of a D2 tetrahedron.
It's geometrically locked.
Exactly. The defining mathematical rule for a tetrahedron is Euler's formula, V minus E plus F equals 2. The number of vertices minus the edges plus the faces always equals exactly 2. This is an absolute topological invariant. Your relative speed or your frame of reference has zero impact on fundamental topology.
So you literally cannot outrun geometry. The shape remains the shape, so the speed remains the speed.
The invariance of light is a byproduct of the indestructible geometry of the lattice it rides on.
That is profound. And honestly, up to this point in the deep dive, I'm just fascinated. We've rebuilt the constants. We have found hidden aquifers of magnetism. We've turned light into geometry. But it is still a theoretical model.
For now, yes.
It's elegant math on a chalkboard. But Chapter 6 of the TDUFT paper claims this isn't just theoretical. It claims it is an engineering manual. Like, how do we pull this out of the chalkboard and build with it?
This is where the framework steps completely out of the realm of abstract string theory and enters the physical laboratory. The paper introduces what it calls the motor law.
Okay, I'm looking at the motor law equation right here. It reads P of d phi equals eta sub zp times the Lorentz force times v sub mech. So what exactly are we looking at here?
Let's break down the variables. The Lorentz force and the mechanical velocity, the v sub mech, represent standard classical mechanics. This is the math governing the electric motors in your EV or your blender.
Okay, the standard stuff.
But the critical new variable is eta sub zp.
The Greek letter eta subscript zp. What does it stand for?
Zero-point coupling efficiency. This is the control knob. It dictates how much of our local machine can reach down and tap into that hidden D10 aquifer of vacuum magnetism.
So in a standard electric motor, like the one in my Tesla or my refrigerator, what is eta zp set to?
Functionally, 0. Standard engineering only utilizes the D6 radiator loop. But TDUFT states that to make eta zp greater than 0, to essentially open the valve to the vacuum, you must create simultaneous D6 classical torque output and D10 vacuum input. And the trigger for this integration is a local entropy reversal.
Whoa, hold on, stop right there.
I know.
You just said local entropy reversal. My college physics professor would throw an eraser at my head if I suggested reversing entropy. The second law of thermodynamics says entropy disorder always increases. You can't just pull free energy out of the vacuum. That violates the fundamental conservation of energy. Every physicist listening to this is groaning right now.
Their skepticism is entirely justified by classical models. If you claim to create energy from nothing, your theory is dead on arrival.
Right.
But the paper is meticulous in addressing this. It does not violate the global conservation of energy. The mathematical identity driving this is D10 equals D7 times D3.
You're going to have to explain how multiplying depth 7 by depth 3 saves us from breaking the laws of thermodynamics.
It means the energy isn't being magically created out of a void. It is being transferred across dimensional boundaries from the geometric tension of the lattice itself. The universe possesses an underlying reservoir of highly ordered geometric structure. A local entropy reversal just means you are tapping into that existing order and moving it to your local machine. Think about your refrigerator.
Why refrigerator?
Does a refrigerator violate the laws of thermodynamics by making the inside cold, basically lowering the local entropy of your groceries?
Well, no, because it uses a compressor, it draws electrical power, and it violently pumps a bunch of hot air out the back into my kitchen. It lowers entropy inside the box by increasing entropy outside the box.
Exactly. The exact same principle applies here, just dimensionally. The motor law dictates that by engineering a system to the right geometric proportions, you can act as dimensional refrigerator. You pull ordered energy out of the D10 vacuum and dump the corresponding entropy debt into a different dimensional shell. It is a transfer, not a creation.
Oh, wow. Okay, let's use a windmill analogy then. If I set up a wind turbine in an empty field and it starts spinning and generating electricity, I am not magically generating free energy. I didn't create the wind.
Right.
I just angled my turbine blades perfectly to catch the atmospheric pressure gradient that was already moving across the field.
The energy was already latent in the environment. You just built an antenna to harvest it.
So TDUFT is saying the vacuum of empty space is constantly blowing with wind, this intense geometric tension of phi and psi. And we just need to build a precise enough windmill to catch it.
And the paper tells you exactly how to build those blades. It provides highly specific, testable predictions. By matching the winding radii and turn counts of a magnetic coil to golden ratio proportions specifically scaled to phi to the power of 2K, an engineer can align the additive nodes of the physical wire with the multiplicative peaks of the vacuum's geometric waves.
You literally build a physical coil of wire that resonates with the mathematical shape of space itself.
When you achieve that resonance, the predictions are staggering. The paper states that phi-tuned coils with radii cut specifically to phi cubed or phi to the fifth should produce 5 to 20% excess torque above the classical Carnot limit.
5 to 20% excess torque. I mean, in the world of mechanical engineering, where companies spend billions to make a motor 1% more efficient, pulling 20% extra torque seemingly out of nowhere is a massive, highly measurable anomaly.
It would change the world.
Are there specific materials required to pull this off? Like, can I just use copper wire from the hardware store?
You can see slight effects in standard conductors, but the paper explicitly highlights carbon. specifically carbon nanotube coils. It predicts that carbon coils wound at these precise golden ratio dimensions should exhibit 10 to 100 times the torque enhancement of a standard copper coil.
Why carbon? What makes the stuff in a pencil so geometrically privileged?
Look at the atomic structure. Carbon's atomic lattice is geometrically much closer to the vacuum's D2 underlying Phi lattice than copper's metallic structure is. Carbon atoms naturally arrange themselves in hexagonal and pentagonal symmetries that deeply resonate with the vacuum. It is the perfect bridge material between the mechanical world and the quantum vacuum.
Okay, more torque is cool, but my notes also say something about weight transience.
Yes, the paper predicts that if you take niobium rings, niobium being a superconductor, and subject them to these specific resonant frequencies, the rings will exhibit mass fluctuations on the order of 10 to the -8 grams.
Fluctuations in mass, you are talking about localized anti-gravity.
Logically, it has to be. Remember Duca's third law from earlier. Gravity isn't a separate force. It is just psi to the fourth time contraction. If your resonant coil is actively manipulating the local psi density by pulling energy from the lattice, you are inevitably manipulating the local gravity field. Changing the local geometry changes the local weight.
That is wow. It all connects back to the beginning. The theory holds together at every level. And the fact that carbon is the primary key to unlocking this engineering leads us directly to the grand synthesis of the paper. It's the mechanism that unifies the microscopic quantum world with the massive cosmological world.
Right. Chapter 7, the O1 duality and the three ladders.
Yeah.
This is where Dukas attempts to prove that everything from a photon to an electron to a galaxy is just a different expression of the same fundamental code.
Walk me through this O1 duality. What are the two modes?
The universe operates on two distinct geometric states. Mode 0 is the state of separation, or waves. Mathematically, this occurs when phi plus I equals 0. When the expansive operator and the contractive operator perfectly cancel each other's physical form out, you don't get a solid object. You get a propagating wave. You get a field.
Okay. And mode 1?
Mode 1 is the state of joining, or particles. This occurs when phi to the -1 plus phi to the -2 equals 1. When the inverse harmonics sum to unity, the operators achieve topological closure. The geometry folds back on itself and locks. That closure creates what we perceive as mass. It creates a physical particle.
Let's ground this with an analogy. Imagine you are sitting in a grand concert hall listening to a cellist. Mode 0 is the sound wave traveling through the air across the hall. It's expanding, it's propagating, it's a field of acoustic energy interacting with the room.
Nice, yes.
But mode 1 is the standing wave vibrating on the actual physical cello string itself. The string is locked in place between 2 points. It has physical presence, tension, and mass. But underneath it all, both the string and the sound it makes are just manifestations of the exact same vibrational mathematics.
The acoustic analogy captures the essence perfectly. Mode 0 and Mode 1 are just two behaviors of the same lattice. And these two modes organize the entire universe into 3 infinite families, which the paper calls ladders.
Wait, what are the 3 ladders?
First is the induction ladder. This is governed by Mode 0. It contains all the fields, the electric fields, the magnetic fields, the propagating light waves, and the infinite vacuum aquifers we discussed earlier.
So the acoustics of the concert hall.
Right. Second is the Dirac ladder. This is Mode 1. It contains the lightweight particles, primarily the leptons. This is where you find your electrons, your muons, your tachyons. They are the initial, lighter, physical closures of the geometry.
The later strings, and the third.
The nuclear ladder. This is also Mode 1, but at a significantly deeper, more complex dimensional level of topological closure. This ladder generates the heavy baryons, the protons and neutrons that make up the core of every atom.
This actually solves a massive headache in physics, because right now, quantum field theory has a really hard time explaining how a field is different from a particle, and we invent all sorts of particle wave dualities to explain it. But TDUFT just says they aren't different. There is no separate theory for particles and fields. They are just the 0 and 1 states of the golden ratio geometry locking or unlocking.
Exactly. And if you want proof that these ladders are real and not just elegant mathematical sorting, you just have to look at the anatomy of the carbon atom. The carbon atom is the ultimate physical manifestation of the entire TDUFT lattice operating in perfect concert.
Break a carbon atom down for me using these ladders.
At the center, you have the nucleus, 6 protons and 6 neutrons. In TDUFT, that nucleus is a Mode 1 closure existing deep down at the D11 dimensional depth of the nuclear ladder. It is a profoundly dense knot of psi contraction. Orbiting that core are the electrons. These are also modal enclosures, but they exist much closer to the surface, at the D3 depth on the Dirac ladder.
So we have the heavy knots and the light knots, but what about the bonds? How do carbon atoms stick together to form, say, a diamond or a sheet of graphene?
The covalent bonds connecting the atoms are mode-zero lattice currents. They are flowing waves operating at the D2 level on the induction ladder. When you arrange billions of carbon atoms into a perfectly repeating diamond crystal structure, that physical diamond lattice seamlessly extends the microscopic quantum geometry all the way out into the macroscopic D10 vacuum geometry.
It scales up flawlessly. The microscopic and the macroscopic are literally built on the exact same scaffold.
And the math backing this up is astonishingly precise. TDUFT doesn't just say electrons and protons are on ladders. It derives their exact masses.
Really?
Yes, the mass of the electron, which is 0.511 rho v, and the mass of the proton, 938 MeV, emerge strictly and precisely from the specific intersection points of the phi and psi crossing on these dimensional ladders. The theory even derives the mass of the elusive Higgs boson, which is roughly 125 JeV, not by assigning it an arbitrary scalar field value, but strictly through the recursive dimensional geometry of the lattice.
Wait, it mathematically derives the mass of the Higgs boson from the Golden ratio.
Yes. It strips the standard model of its arbitrary parameters and reconstructs them from pure topology. And it all relies on that Euler characteristic we mentioned during the speed of light discussion, V minus E plus F equals 2. That topological seal holds true on every single shell of reality. It dictates the D2 photon wavefront, and it holds mathematically true all the way up to the massive D23 boundary of a supermassive black hole. The atomic maps perfectly to the cosmological.
Man, if it scales all the way up to the cosmos, I have to ask about astrophysics. Because the biggest headache in astronomy right now is dark energy.
Oh, dark energy is a mess in standard physics.
Right. We look out at the universe and we see it expanding faster than the matter in it should allow. So astrophysicists just invented a placeholder concept called dark energy to make the math balance. It's basically a massive fudge factor that supposedly makes up 68% of the universe. Does TDUFT explain it?
It doesn't just explain it, it eliminates the need for it entirely. In TDUFT, dark energy isn't a mysterious new substance or a hidden repulsive force. It is simply the cumulative geometric effect of psi contraction across the infinite expanse of the lattice. When you sum the contraction across all dimensional decks, the math yields a baseline structural tension of approximately 0.382.
So the expansion of the universe isn't being pushed by a mysterious energy. It is just the natural geometric tension of the lattice balancing itself out.
Precisely. It completely removes the need for highly speculative cosmic inflation theories or undetectable dark matter particles. Dark matter is just the gravitational shadow cast by the geometry of the lattice itself.
The theory just cleans house. It really does. A good theory has to do more than just explain past mysteries. It has to make predictions about things we haven't found yet. Does it predict anything we can go look for in a particle collider?
It makes extremely concrete predictions for the future of particle physics. If you extend the math of the Dirac ladder further up the dimensional scale, it mandates the existence of a brand new undiscovered lepton particle at the D15 shell, sitting somewhere in the 10 to 100 GeV mass range. And it predicts the existence of super-heavy baryons sitting beyond the D27 shell that we should be able to detect in the collision data of high-energy cosmic rays.
So, if the scientists at CERN fire up the Large Hadron Collider, recalibrate their sensors, and spot a new lepton exactly at that D15 energy level, this entire geometric framework is vindicated.
If that observation is made, TDUFT will trigger the most profound paradigm shift in physics since Einstein published general relativity. It would mean the universe is solved.
We have covered an incredible amount of ground today. We started with the frustration of memorizing random constants in high school physics. We dove into the roots of a simple quadratic equation, x squared minus x minus 1 equals 0, and watched phi and psi unfold the entire universe. We saw how Maxwell mapped the surface radiator of magnetism, missing the massive D10 vacuum aquifer hiding beneath.
It's a lot to take in.
It is. We learned that light doesn't just fly through empty space. It drags across a fractal geometric lattice, governed by math written by Ramanujan a century ago.
We move from the microscopic geometry of the carbon atom to the cosmological scale of dark energy and black holes. And the through line is that the universe is not a chaotic collection of random dials. It is a singular, unified, deterministic structure.
And if we can master the engineering of that structure, if we can build the golden ratio carbon coils to tap into that vacuum, we are looking at a fundamental revolution in how humanity interacts with energy and gravity.
The engineering potential is limitless.
But before we wrap up this deep dive, there's one final provocative thought that I just can't shake. We've talked about the math, the vacuum, and the carbon atom, but we haven't talked about us.
The role of the observer.
Exactly. Think about human biology. Our brains, the incredibly complex organs we use to study physics, are built predominantly out of carbon atoms. And as the paper painstakingly laid out, carbon is the perfect geometric bridge. It flawlessly connects the D2 local quantum shells to the immense D10 vacuum shells.
Carbon is the structural keystone of the lattice.
So, if the universe is fundamentally an eternal deterministic lattice, where does human consciousness fit in? Are our brains just wet biological computers running survival algorithms? Or, because of our dense carbon structure, are our neural networks geometrically hardwired into the infinite tension of the vacuum itself?
It strongly suggests that consciousness might not be an accident of chemistry, but a structural inevitability of the geometry.
Are our minds merely the lattice's way of finally waking up, looking around, and calculating its own geometry? We aren't just living in the universe, we are the universe geometrically computing itself.
It is a stunning philosophical consequence of the math.
It's enough to make you look at a simple graphite pencil or the diamond on a ring in a completely different way. I want to thank you all for joining us on this deep dive into George James Ducas's TDUFT Maxwell Revised. If you're driving or washing the dishes or just sitting at home, take a second to look around. Look at the light filling the room, feel the gravity holding you firmly in your chair, and try to imagine the invisible, breathing, golden ratio geometry flowing through all of it, making it possible. Because suddenly the random, muddy junk drawer of the universe is looking incredibly beautifully clear